So
Thanks,
yep, it's all good now, Jo. Over
thank
to you.
you. There's a bit of an echo. Maybe,
Maybe I should mute.
yeah, please. Thanks. Okay. Yeah, thanks everyone. Today is going to be another session for the vector databases. We were not able to complete it last week, but yeah, I think it was exciting, right? I guess before we start, I'd like to know if there's any questions quickly while I set up my environment.
None from me. No questions.
Okay. If that's the case, I'll just do a quick review and then we can proceed. Okay. Right. So last week, it was all about vector databases. We saw and tried to understand what vector databases are, and we saw this chart with 3 features. Just a reminder that we call these features. Sometimes people call it dimensions, latent factors, or properties, but they're really basically just another number, right? So just to review, for a 3-dimension vector, we had a list of 3 numbers. Each number basically represents a property of that particular object. Because it's a vector, it's actually, the properties are actually unnamed. So in this example here, we just named it for convenience and to kind of understand what it is about. We also saw this, I guess, illustration on how we would visualize such the data, the embedding that we have here, and how the data is actually represented in the vector space. And what's a cool thing about vectors is actually, because they're numbers, we can actually express. They have actually have a meaning, right? So the embedding has a meaning, and visually, when you look at it in a 3-dimensional embedding like this, things that have the same meaning are closer together. Not only visually, when you actually do a similarity search with vectors, the libraries actually have functionality to find do similarity search from one embedding to another, right? And to be able to do that, internally, it's using some mathematical, because embeddings are numbers, it's using some mathematical attributes called something like cosine, similarity, Euclidean distance, all those things. But you don't have to worry about that for now. Just believe me that once you have an embedding, you can actually find a similar embedding based on the one that you have. I think this is where we stopped the last week, where we wanted to set up PG vector. Right, PG vector, to remind everyone, is a Postgres SQL. It's an extension to Postgres SQL to enable you to have or support the vector functionality in your database. A reminder that Postgres is quite a popular database. I'm sure many of you guys in the call has used them before. But what's nice about it is, especially me for a developer like myself and many others, is any SQL database is quite approachable, right? It's quite easy for developers to use, and we're actually using it in our day-to-day if you're a developer. So that means instead of using these new vector databases are sorry, instead of using single vector databases like ChromaDB and Pinecone, this is one of a good option to use. So I'm not sure if anyone has run this Docker statement to basically set up your Postgres in your local machine? So Tony, how was your experience with that? Like, was it successful or?
Yeah, thanks, Joe. Yeah, it was successful. I
Uh-huh.
got another question for the choice of using Postgres. Is it because I'm just wondering, um, is the Postgres is able to handle some high availability issue?
Just Postgres is quite a robust choice, right? In terms of not even talking about vector databases. It is a very robust transactional database, and typically when you deploy on the cloud, I'm working on AWS. Our customers, when we help them with their databases, we always suggest them to put it in a managed database like Postgres has a managed option in AWS, right? So that means you can set up all those redundancy, all those functionalities that make it really robust. And yeah, I think it's proven, right? So there's actually there are a lot of options, but what I'm trying to say is Postgres is a solid option.
Thanks. Yeah, because I saw someone even use Elasticsearch. So I just
Yeah, there are a lot of options, right? And different levels of capability and different levels of price. Elasticsearch is a little bit something similar, but it's got lots of more options. And in AWS, there's really really good option, but quite expensive, Kendra. And you've got a lot of options, but don't worry about that. I guess we know that. PG Vector is still a solid choice. So especially now when maybe you're building up your confidence and your knowledge with vector DBs, you want something that
Sure.
for me personally, I've played with
Yeah.
Postgres before, so
Yeah.
I'm quite familiar with it. Playing with it locally. Yeah.
Yeah, thanks. I just want to understand in the future, maybe we could think about how
Yeah.
to the more available for the whole system. Yeah.
Yeah.
Thanks for that. Yeah. Thank you.
Any more questions? Okay. Cool.
Hello? Can you hear me?
Yeah, has a question. Yeah.
Sorry, I think just to add on that, I remember Postgres has always been the top choice even in Stack Overflow survey. I guess that's the most production grade enterprise RDBMS out there. I think I'm just looking at it now. It's Postgres 48%, then followed by MySQL, then SQLite. I mean, that's the Stack Overflow only. But
Mm.
yeah, I think it's battle tested, right?
Yeah.
Sort of like the database RDBMS of choice.
Yeah, I think so. Yeah. Vishal had a question. I think he raised his hand.
Vishal?
Yeah, hey guys, Vishal here. This is my first time joining here.
Oh, welcome.
Yeah, I got interested because of this vector DB. Because so I was looking into OpenSearch in AWS, and when I was setting up OpenSearch, we had this embedding models from the what do you say, Bedrock. So
Yeah.
I could select the Bedrock embedding models. But when we are using different database altogether, that is Postgres. So do we have to also be choose the embedding models based on the database as well, or
No.
is it
You can choose. Pick whatever embedding model that you like, right? So, in our example today, in module 3, we picked a local embedding model we deployed we loaded in LM Studio. So we've got module 1 and 2, and where we set up our local LLM. In addition to loading or loading your local LLM, you could also load your embedding model locally, right? So that's one thing. Embedding models are actually quite light, right? So you'll notice that you've got a few options. Loading it locally, you can get an embedding model from something like Bedrock, embedding model from OpenAI, or even from Hugging Face, right? So we also have that here where we download an embedding model from Hugging Face, load it in memory and locally, and basically run that embedding model locally, right? So because it's quite light, it's really just a function that generates a number, right? So you can do it like that too. But for if you're really in production, you want something that's deployed, and something like an OpenAI or in Bedrock.
Yep, cool. Thanks. Thank you.
Okay. So yep. So if you run that, if you haven't run that before, you run that Docker run command. It basically runs a Docker container containing Postgres. I won't explain a lot about it, but it's using that base container from already containing PG vector installed. Right. So once you run that, for people who know Docker, you'll see that your container will run. Your container is actually running with in this example, I said, okay, I'm gonna call my container Code.Sydney, and it's running as Code.Sydney. I wonder if I can bring up my Docker desktop quickly. Not sure if you can see my Docker desktop, but okay, I'll do that later. I'm having some issues with my screen, but that's cool. Just believe me that once you run Docker with that Postgres in a container, then what you do is you actually connect to it using, hey, Engramar, what did you use? Did you use PG admin?
Yes, I use PG admin. Yeah.
You can use any favorite, I guess, SQL client that you like. PG admin. I use dbeaver, but you can use like Datagrip or something like that, right? So even I have Datagrip here somewhere. Yeah, okay. So this is kind of like a client for my SQL server, which I installed locally, and this client, you can basically connect to your databases. What's nice about PG Vector is it's just it's really just any other SQL database, right? So you can connect to the table created by Llama Index. I'll show you later where this is, and you can connect. You can have a look at the columns and the data which is ingested in your machine, in your container. And what we really want to see is how does an embedding look like, right? So an embedding is just a list of numbers, right? So that's all. I'm just going to copy and paste it here so that you'll see. It's basically a list of numbers, and the size, the dimensional. This embedding model has a 768 dimensions. We'll see that shortly. So that's it. Once you see, that that vectors are just a list of numbers, then that's all there is to it, really, honestly. So yeah, this is basically just setting it up, creating the database. So I had to do that, before I started, and then once it's set up, then yeah, this is basically what you saw live in the other screen, where you see your database running locally. If you have issues with hardware, what you can do is what Engramar did: connect to EC2 instance and then install PG Vector Postgres there, and install PG Vector. And yeah, you can also do it that way. But this is probably, if you have the hardware for it, your laptop's good, then you could basically install it locally. So that's really all there is to it with
A quick question, Jo.
yes,
Sorry.
yes, please.
Where did you get the data, by the way, to be ingested in the database, in the vector?
Okay. Yeah, I'm going to cover that short next actually. So
Sorry.
yeah,
Oh,
that's
by the way, another thing, Jo, if they want and if they need any help, to set up an EC2, I'm happy to support them as well. Yep.
there you go. Like, and Gurmar's there to lend you a hand, right? So okay, quickly, we only have 10 minutes, but okay, let's have a look at the notebook, and then we'll see how we ingested the data. So you would have seen this notebook. So you already know what's happening in the first few cells. Okay, this one is using CyclePG2. CyclePG2 is a Python library for connecting to Postgres databases. It's not really only used for embedding, PG vector. So remember before I said that Postgres is quite popular for the dev community. This is a really old library that people has been using for years to connect to Postgres database. And surprise, surprise, you can still use the same library for talking to your vectors. Yeah, these are really all connection string, just connecting to it. Here I'm saying I'm just gonna create a new database every time. Just for this exercise. So whenever I run this notebook from top to bottom, there's always a new database created from scratch. So here, what I'm doing is, okay, so we have, okay, so remember, we are hosting our embedding model, right? The embedding model is hosted in LM Studio, and you run a local server in LM Studio on localhost port 1234, right? And that means your embedding model actually is available in that port, and you just use OpenAI. You can actually use OpenAI, even though we're not talking to an OpenAI embedding model, because it's in LM Studio. We can talk OpenAI. We can use OpenAI to talk to our local embedding model. So this is my local embedding model, Nomic. If you remember LM Studio, I've run Nomic as an embedding model. So I can actually do that and talk to that embedding model. It's probably better if I go to my Visual Studio so that you can actually see it running, right? So back here, we run this cell and talk to our local Nomic embedding model running locally using OpenAI. Rinesh has a question: how do you select the right embedding model? There's no wrong or right answer, right, Rinesh? However, it's just like different embedding models have slightly different, I guess, capabilities. What you can do is have a look at in Hugging Face. There's an MTEB leaderboard, right? MTEB. How come that's not working? Sorry, my keyboard's not working. Okay, there I go. MTEB. Right. So MTEB leaderboard is basically leaderboard maintained by Hugging Face, and that would give you some indication on how good an embedding model is, right? So I would think any embedding model, the top 20 should be really good, right? So in this case, we used Nomic. I'm not sure where Nomic is, but yeah, that's basically the answer.
Okay. No, my main question was is there a supported embedding model for a particular LLM that we use? So,
no. You can use any, right? So here, I think Tony asked a question earlier, or maybe I'm not sure, but yeah, you can actually use whatever embedding model you like, right? So in this case, I can pick Nomic, or I can pick Titan in AWS, or an embedding model in OpenAI. That's fine. It doesn't really matter. All you need to do is just use whatever embedding model that you like. It comes back with its own, list of numbers. You basically just persist that in database, and yeah, database doesn't care. It just uses whatever numbers it's passed to it.
Great, thanks.
So that's the first option.
Looks like you have a question, Jo.
Yes.
From Alec. It says there, we import many libraries. How do we remember those? Which libraries to import?
Okay. Repetition, you'll remember, right? Just like anything in programming, the more you use it, you'll form your favorites, especially as you build your applications. So here I'm just giving you some options. The first one is using OpenAI to talk to your embedding. The second one is using Llama Index, which is another OpenAI embedding functionality, but you can pass using the local LM Studio here too. So it's really by preference, right? So you can use OpenAI if, for example, you already have an application that uses OpenAI, and then you can continue using that. Or if you're building an application from scratch, I'd pick one of the libraries, orchestration libraries like Llama Index or LangChain, I think, and you can do it that way. So that means in here I'm using Llama Index, and I was still able to talk to my local embedding. That's the same local embedding I used through OpenAI API, right? And then just the same, if you run, sorry, wrong one. Just the same, if you run this Llama Index OpenAI embedding one, I will it would return with actually the same embedding generated by the OpenAI library at the top. So see 032, and it's the same one, 032, right? Because we're basically passing the same string. We're getting an embedding of that, and then getting the embedding from the same embedding model. And then finally, we're not using any of that. We're not using any of the embedding model hosted locally, right? We're not using Nomic. What we're doing is, as I mentioned earlier, you can actually download, because embedding models are quite light, right? Compared to an LLM. LLMs like gigabytes, but embedding models quite light. They're really just functions, right? So few kilobytes. What you can do is just use Hugging Face. There's a lot of embeddings in Hugging Face. Just pass in the embedding model that you like, and based on that website I showed you earlier, MTEB, just find embedding in Hugging Face and just use that, right? And then what that does is it actually downloads that embedding model, the binary, in your local machine, loads it in your memory, and then once it's there, you're actually running the embedding locally without any server, right? So if you run that, there's a little bit of a delay when it's downloading the thing, this embedding model. Previa, BAAI is Beijing Academy of Artificial Intelligence. So it comes from China. Yeah, question. 5 minutes. Okay, let's go, so that we don't have to continue next time. Finally, we're now in the ingestion part, right? So we now have our Postgres running locally. We now know how to talk to or get an embedding of a text using any of the libraries that we mentioned above. So now we can actually do some ingestion. So what we do is point our program to a folder, Here we pointed to a data folder, right? So Ingramar, I'm answering your question now. So you pointed to the data folder in line 12. In the data folder, we have an MD file, right? And the markdown file really contains just the README file of our repo. You've seen this before, right?
Yep.
Yeah. So that's what we're ingesting. And then I'll close that. Come back here. I've got one function called vector DB ingestion. And what it does is uses a simple directory reader from Llama Index. Simple directory reader is a general purpose. You just point it to a folder and then it will ingest whatever it is in there, right? So typical things like markdown files, text files, PDFs will be ingested if if you need that default behavior. But you can actually specify specific behavior. But for now, don't worry about that. Now just point it to a folder, then you call the load data, and it will generate the nodes for you in memory. Once you have the nodes, right? These are the nodes that you will send to PG vector, right? And then once it's sent to the PG vector, right? It will be persisted as those nodes will be persisted as embeddings in the vector database. So let's run that. Actually, haven't done anything. I'm just defined the function, right? So I'm just defined the function, and then we're actually running it for real in the next cell. So what we do is call that function vector DB ingestion. We know the vector size because we saved the vector size here at the top. I think whereabouts is it? Here, right? And then we know that the vector size is 768. In this particular embedding model, is a small embedding model, only 768 dimensions. And then finally, okay, next one is we're basically creating a retriever for that. That's another Llama Index object. And then we're saying similarity top K. Top K, when you see this top K, is basically saying when you search something in the vector database, when you retrieve something, just give me the top K, top two, the first two items in it. And verbose is just so that you can see things running the progress bars. So that was quick. We only have a very small file, a README file. It only contained 4 nodes. Nodes is basically like the chunks. And here I'm just writing down just for debugging so that you can see what it is. Right. So just play with that. We're running out of time. I think that's it. And then finally, once we have the retriever, right, you can basically just use the retriever and send a question to it, right? So the question is, what does Code.Sydney do? It searches that in the database and then returns the nodes that contain the data. Okay, and then finally, in the database, have a look at, we've got 4 nodes in there. Just do that again. Sorry, I haven't deleted it, but yeah, I'm supposed to see 4 nodes. I've overwritten 5, 6, 7, 8 nodes, but you'll see 4 nodes, and then you'll see the embeddings on the right side here. Okay, that's all.
Just in time. Yeah, Gio, thank you very much.
Okay, see you
Insightful
guys
as always.
next week.
See you next week. Yeah.
Let's start with RAG finally next week. Okay.
Oh yeah.
Yeah.
Looking forward to it. Okay.
Thank
Bye bye,
you.
guys. See you.
See you. Bye bye.
Cheers, Gio.